Thanks for tuning in. We all know that generative images and generative videos are taking over the world. I'm here to talk about how the evaluation of these models and videos is still flawed and challenging, and what needs to be done to make it better. We live in a very visually rich world. Visual medium is how we talk, we connect, we interact with our family and friends. Going beyond social interactions, visual medium offers a way to creatively express ourselves and to share our knowledge with others. It has also enabled us to design embodied AI systems and build assistive devices and aid in several tasks. Given the very high volume of video data around us, not every video that is being captured and processed is perfect. There are a number of nuisance parameters such as bad network conditions, bad compression artifacts that can interfere with the visual quality of these videos. Let's say we're trying to take a picture from a moving car. That interferes with the quality of the video or the picture that we take. Or we're trying to take a video in very low light conditions. So that again, like the consequence is a low quality or a bad quality video. Beyond these factors, there are other scenarios such as display device on which you are trying to view the videos that can interfere with our perception of the visual quality. Same goes with the different spatial and temporal distortions and how it interacts with the image and video content. And again, finally, it all depends on what we prefer and what we like. So aesthetics and human preference also play a big role in our perception of visual quality. All of this is to say that human opinion is the ultimate gauge of how we perceive and experience the visual quality of particular videos. So there has been a lot of progress just in the past couple of decades in trying to build models and metrics that can emulate how our visual system perceives the visual quality. So right from like 90s when we were trying to design very simple algorithms all the way to right now where we are designing advanced AI models, the fundamental goal has remained constant, which is to emulate how our human brain perceives visual quality and try to build a model that can do that for us. So I've talked about real videos which are captured by humans and how to evaluate them. Now let's talk about generated videos. Just in the past 1 year, there have been several models from Runway, Pika Labs, Meta, OpenAI that now are able to generate photorealistic videos with extremely high fidelity. And the photorealism is almost on par with how humans capture real world content. So how are these models evaluated? How are we determining that model 1 is better than model 2? To understand that, let's take a step back. In a traditional machine learning system, the way evaluation happens is as follows. We start with a set of curated test datasets. Let's say we want to evaluate if a particular object classification model. So we go about collecting images of cats and dogs, have humans label these images, and then come up with a set of metrics. In the case of classification, it could be accuracy. How accurate is my model in predicting cats versus dogs? And then we go about comparing our fancy method that we've developed with some of the other existing models that are out there. How do we do this for generative models? So here, there's no curated test datasets. We have prompt collections, but they're not widely adopted by everyone. We have a few quantitative metrics such as inception score and clip score, but they're very heuristic based. They are primarily tailored for images and they don't work well for videos. Again, the onus falls back on human opinion score, where again, humans have to watch thousands of videos that are generated by different models and pick which video is better than all of the rest of the videos. So as I mentioned, because there are no prompt collections, every model that people are publishing, they tend to evaluate on their own collection of prompts, so there is no uniformity in how models are being compared. Quantitative metrics are heuristic approximations. Qualitative is the ultimate way to measure, but again, it's hard to reproduce, it's expensive, it's time consuming. In the next couple of slides, I'll share some insights on what we have so far and what's missing, so we can think about like what the research can focus on in the next coming years. So when it comes to curated prompt collections, we have something called Party Prompts that was released by Google. It's a collection of prompts primarily targeting image generative models. The prompts are categorized into different aspects, such as prompts which have complex details, prompts which have different properties and positioning and finer grained information about objects. So that's great. That's a great collection, but it doesn't capture any temporal information. So this works well for images, but not so much for videos. Drawbench, in the same spirit, is another collection of prompts, but again, tailored for image generative models. So that's the lack of prompt collections. Let's jump into the metrics that we have so far. There are a lot of metrics, but just in the interest of time, I'll focus on one main metric, which is clip score, which is very widely used in the literature. Clip score is used in research in two different ways. For the first is to measure frame consistency. So let's say your model generated a particular video. You want to understand if the generated video is temporally consistent and temporally smooth. So one way to do that is extracting clip image features across different frames and computing a similarity between them. If the video is smooth, then the similarity score between adjacent frames should be high. So this intuitively makes a lot of sense, but in practice, it has been shown that this is a weak indicator of temporal consistency. And that's largely due to what information is packed in the clip image features. A more frequent way of using clip score is for prompt consistency. So again, like imagine you as a user are prompting a model to generate a video. What you would ideally like is that the generated video captures everything that you describe in the prompt. So this is called prompt consistency or prompt alignment. And again, the way that this is measured in the literature is you extract clip text embeddings of the prompt itself and the clip embeddings of the image or the video and compute a similarity between them. High similarity indicates the text and the video are more closely aligned. This again seems like a very reasonable metric to use, but again, let's see how it works in practice. Here is an example of two images, one generated using Stable Diffusion 1.5, the other 2.1. The text prompt is shown below. Let's try to dissect the text prompt. Let's look at the first phrase, which is sitting on a horse. We can see that both models are able to capture that correctly, generate that correctly. So there is a person sitting on the horse in both images. The other phrase is horse in air. And again, you see that one of the models is not able to accurately synthesize it or generate it. The third object here is gate. You again see that gate is missing from one of the images compared to the other. So you'd think that given one of the models is consistently missing certain details, the clip score, the clip similarity score, should be lower. But that's not the case. So we've seen this consistently across images, across different videos, that if the prompt has a lot of detail, then the clip score is not a good indicator of the prompt alignment. So just as a summary, again, just to not leave people hanging, there are other works that are happening where people are trying to use other tools to measure prompt alignment, such as visual question answering. But clip score is still the de facto metric that is still reported in most papers. And it's primarily because it's quick and easy to compute. Although it's a frame-based metric, so it works well for images, not so well for videos. And the biggest complaint or challenge of these metrics is that they do not correlate with human judgment. And that's extremely important because human eye, again, is the final consumer of these videos. So we have to make sure that it aligns with human opinion scores and human judgment. So as I've been saying, this is a huge unexplored area of research, a very active area of research, like evaluation techniques. So far, I've mainly touched upon three different aspects. I've talked about like photorealism, that the images of videos that are generated should be highly photorealistic, should be aesthetically pleasing, should have high visual quality, and also align very well with what a user is asking for. But that's not the end of the story. We also want to make sure that our model is not enabling generation of deepfakes or generation of extremely violent or pornographic content. We do want to make sure that the generative media that is being put out there is not biased towards one demographic compared to the other. We also want to make sure that we are protecting the artistic styles of certain artists, and the models are not blatantly copying or stealing others' artistic styles. So, how do we measure all of these different facets of a generative model? So that's where the challenge comes from, because unlike a simple classification model where there is a very well defined task, which is make sure the model predicts cats versus dogs, evaluating a generative model has multiple facets, and all of these are very complicated in nature. So, just in the interest of time, I'll focus on one particular metric, which is fairness. So, this is a study that was published in 2023 by researchers who've prompted the existing text to image models on different professions. And they found that when they prompted models on relatively high paying jobs like architects or CEOs, then the generated images typically had people of perceived male gender and lighter skin tone. But when the same models were prompted with relatively lower income professions, such as a janitor or a nurse, then other gender groups and other skin tones emerged. So, again, this is not entirely a true depiction of the real world. This is what the generated model is producing, and this is what we want to mitigate. One mitigating solution that has been adopted by DALI 3 and other tools is to rephrase a particular prompt by adding specific qualifiers. So let's say you're prompting for photos of a CEO, then internally in the backend, this prompt is modified to add certain qualifiers related to gender, ethnicity, or age group so that the consequent outcome is more diverse. But we've just seen a couple of slides ago that prompt adherence or prompt alignment is a big question. It is possible that we can provide a prompt with certain qualifiers, but there are no guarantees that the output will have those attributes. To address this, some recent work of ours at Runway tackled this from a different angle. So our idea was straightforward. We wanted to expose the model with diverse evidences of a given concept. So if the concept here is profession of a CEO, during training, we wanted to just show the model different data points which are more diverse in nature along different axes. And the hope was that this will broaden the visual interpretation of what a CEO should look like. So we started off with coming up with like a prompt template, and we used around 57 different ethnicities and 120 odd different professions and inserted these different age groups, ethnicities, gender, and professions into this prompt template. And that led to about 1000K different prompts, but these are very templatey in nature. So we again fed it to a GPT to paraphrase them so that they're no more natural sounding. We then used an off-the-shelf text-to-image model to generate a bunch of synthetic images. Now, these synthetic images were then used to train a bunch of text to image models that are publicly available. I want to highlight that during evaluation, we don't add any explicit qualifiers. So if the input is generate images of a CEO, nothing happens in the backend to modify these prompts during evaluation. And with this simple fine-tuning trick, we found that a bunch of different models were able to now generate images of people of different skin tones, different ethnicities, different gender groups, thereby just diversifying a concept of what a particular profession should capture. So far in the past 10 or so minutes, we've looked at a couple of these axes, which is fairness and prompt alignment. But again, this chart hopefully highlights that there are so many different aspects and axes that we need to measure to ensure or guarantee that a particular generative model is better holistically. So some of my key takeaways here would be that most of the metrics that we've seen so far are frame based. So more work needs to be done to design models which are video centric. These metrics are not robust. They're very brittle. They work on certain videos but not on others. So work towards building metrics or evaluation systems that are more consistent and robust would be very helpful. Again, the primary consumer of this generative media is the human eye. So it's very important to make sure that any metric that is being developed correlates well with human perception. And videos, as mentioned, introduces a whole different world of issues such as temporal consistency, character consistency, if the motion is realistic in nature, if the motion is physically feasible. So building metrics that can capture all of these is very important. Again, not all hope is lost. I've mentioned this before. This is a very active area of research. I'm very hopeful that very soon there will be metrics across different axes that we talked about, and they would be robust and we can easily adopt. So finally, we want to briefly cover about benchmarking and the tools that are available that enable us to benchmark these different metrics. So something that was recently published is Eval Crafter. It's a one place or a framework or a pipeline to exhaustively evaluate all of the models that are publicly available. So this particular benchmark, it breaks down prompts into different axes such as animals, landscapes, camera styles, actions, and generates a lot of videos and has aggregate qualitative and quantitative metrics that allow us to compare one model against the other on the exact same collection of prompts. So again, this is a very good place. Eval Crafter is a good starting place for us to get a holistic understanding of how one model performs against the other. And more work along this direction would be very valuable in the future. So to conclude, it's very important to develop rigorous and consistent evaluation metrics so that we can run the evaluation at scale consistently across different models. It's equally important that these metrics correlate well with human opinion score because again, human eye is the final receiver of this media. And there is a lot of focus on evaluating along photorealism and aesthetics of the generated videos. But it's also equally important to make sure that the generated videos are not deep fake in nature. They don't propagate bias or unsafe content. So it's equally important that we evaluate along these axes as well. So that's all I've got. Thanks for tuning in. I hope you enjoyed the talk.